Okay, so now we're doing, here in 5.1, changing gears for these last 10 minutes. We'll do what we can, finish up on Thursday. So f of g, let's start this one, f of g, that little circle in the middle, what it means is it means this. That little floaty circle thing means composition, which means composing, right? What does it mean when they compose music? They put all the instruments together, right? That's what we're doing with f of g. We're putting g into f. We're composing them together. Composition of functions. That's what this section is all about. When you plug one function into the other. So that'd be like if I took my microwave, or my toaster, let's go with the toaster, and I put my toaster into my refrigerator. That'd be weird. I don't know where the cord would run out. But maybe if you have battery-operated toaster or something weird like that. So toaster in the refrigerator. What could you get out of that? So just think with me. I want to try to be real with you before we do the numbers so it makes sense what we're doing. So I put my toaster in my refrigerator, take a piece of bread, I put it in the toaster, push down the lever, close the refrigerator door. A couple minutes later, I hear the pop, the toast pop up, I wait a few more minutes, open the refrigerator, pull it out, what do I have?
You still have hot bread?
Chilled toast, right? I don't know why anybody would want that. But my point is, the first function, the toaster, would operate on the bread, do his thing, turn it into toast. And then when that's done, when it pops up out of the toaster, then the second outer function would operate on the toast now, chilling it. That's what's going on here. When you have like -3 like this, it means go into the G function, do your thing to it, pop out of the G function, go into the F function, does your thing to it, and out it comes. You're just running it through both machines. That's what it means, like the bread through the toaster and through the refrigerator. That's all we're doing. And by the way, it does go right to left. That's not a surprise. That's what we always do with functions, right? When I write f of -3, what does that mean? F into -3? No, you know it means -3 into f, huh? With function notation, we always go right plugged into left, don't we? So we're being consistent with that here. So -3 goes into G, then it goes into F. Okay, so how's that work? Let's look at the picture here then. If you take -3 and you put it into G, what pops out? Well, let's read this table, make sure this table's making sense. When X is -3 and you put it into F, what pops out is -9. That's what they're saying. If you put -2 into F, you pop out a -7. If you put -2 into G, you get out a +2. So these are the inputs. These are the inputs, these X values or inputs. And then all of this is what are outputs that come out of either F for the top row or G for the bottom row based on what you put in. Does that make sense how to read that table? So then, get rid of all my scribbles. If we put -3 into the G machine, -3 into the G machine, what's coming out? +3. So, let me just rewrite it here. So I put -3 into G and pop, out comes +3, right? Right here. Out comes +3. The toast comes out of the toaster, and now it's going to go into the refrigerator. The second function, the outer function. Goes in the free. Now when you put +3 into the F function, remember inputs are up here. X's, right? +3 into the F machine, out comes another +3. So the final answer, +3. That's what comes out of the final machine. +3. That'd be the answer to part A. Is that good? Want to try B? See if you can do B. So part B says G of F of 2. So run that 2 through both machines. Start with the F, right? It goes first into the F in this one, and then into the G. The order matters, right? The order matters. Which one's first and which one's second? It's right to left. Functions always are. So you put 2 into the F machine, put 2 into F, you get out 1. Is that good so far? Pop, out comes +1. out of the toaster. Now put that into the G machine. Put positive 1 into the G machine. Positive 1 into the G machine. Out comes negative 1, the final output. Is that okay? Tracing that through? Questions on that? All right. So the graphs and the tables, these are valuable. I remember putting one of these on the exam. I can't remember which one, which is always very helpful. So graph or table, one of these kind is on the exam. So it is important to be able to trace through. So same kind of thing. So we have G of F of negative 1. So you know negative 1's going into the F machine, right? Now how do you do that with a graph? How do you do that with a graph? Well, remember, X is always what you plug in. And Y, X is inputs. Y is what comes out of the toaster, out of the refrigerator, out of the function. X is, on a graph, X is inputs, X-axis, X values are inputs, and Y values, heights, right? And X is over positions. How far over your X value is your input. Heights, those are your outputs, aren't they, on a graph? So with that in mind, let's see. So when X is negative 1 into the F graph, what height, what's the height of the F graph at X equals negative 1? That's what they're asking for the first part. So if you look at the F graph, here's the F graph down here. The G graph's on the top. So there's the F graph. Which dot has an X value negative 1? Well, this one right here. That's negative 1, 0, isn't it? That's X value negative 1, Y value 0. Everybody see that? So that means and that's input output. That's how a graph works. X is input, Y is output. So when you put in negative 1 for X, what comes out of the F function is 0. So what pops out of this guy is 0. Hold on, we have 2 good minutes. These are for your benefit. It's like the dentist. I feel like it's like the dentist, right? You're paying me money, but you'd really prefer a little Novocaine with this lecture. No, I'm just kidding. But you want all that you can get, right? 0 now into the G machine. So what happens when you put 0 into the G machine? So you want to find on the G graph now, up here, on the G graph, where is it? X. Remember what you're putting in? It came out of the F graph, but it's going into the G graph, isn't it? So it's an input to the G graph. This point right here is 0, 3, isn't it? X, Y, input, output for the G graph. So you put in 0 to the G graph, you get out 3. 3 is the answer. Okay, 1 minute left. Let's try this one. G of F of 0. Give it a go. Don't say it out loud. Give everybody a chance. Try it on your own. G of F of 0. Answer is? Does anybody know?
Positive 1.
Good job. Positive 1. Let me trace it with our last 30 seconds. We'll do more of this next time. But 0 goes into F. So it's right here, over 0 down 2. Out comes negative 2 because that's the Y value from the X position on the F graph of 0. Put negative 2 into G. Oh, I'm sorry, 0, negative 1. 0, negative 1. Negative 1 into G. So where's here? Here's negative 1, positive 1 in the G graph. Out comes the positive 1. All right, I know that's probably confusing. We just don't have time to make it more clear. We'll have to talk more about it next time.